Medhavi AI, from Sanskrit meaning intelligent or intellectually brilliant, the perfect name for our AI-powered intelligent learning systems. The prompt: Claude Code Terminal. Claude I, write a Manim scene, Gaussian wave packet in free space, sigma 0 equals 1 nanometer electron mass. Plot sigma of t versus t in femtoseconds. Show the packet width reaching square root 2 times sigma 0 at the doubling time tau. Label the doubling time on the curve. Specify the formula, the constants, and what to draw. The CLI writes it. Read before running. Find this line. Sigma 0 times square root of 1 plus open paren h bar t over 2m sigma 0 squared close paren squared. Two numbers to check. Tau equals 2m sigma 0 squared over h bar. Should be 17.3 femtoseconds. And sigma at tau equals square root 2 times sigma 0, exactly 1.414 nanometers. 30 seconds. Catch it before the render. Run it. Two checks. First, the sigma curve at t equals tau. The marker reads 1.414 nanometers. Square root 2 times 1, exactly. Second, the Gaussian at t equals tau. It is visibly broader than at t equals 0. Same area, lower peak. Both correct. The packet spreads not because quantum mechanics is uncertain about where it is, but because different momentum components travel at different speeds. Iterate. Claude, update packet.py, add a vertical dashed line at tau on the sigma curve, label it tau equals 17.3 femtoseconds. One diff, one rerun. Prompt, read, run, check, change. The packet was the vehicle. The loop is the takeaway. Medhavi. AI-powered intelligent learning systems. On YouTube, at Medhavi AI. Medhavi.com.